So when I got my Ryzen 5900X, I noticed that it would go to very high temperatures under 100% load in, for example, Blender or video rendering. And I thought that that's just the way it was, and I probably need water cooling, but my kind of intermediate fan solution wouldn't be good enough. But what I decided to do was I thought, well, there's some options in the BIOS that kind of look like maybe they were trying to overclock out of the box. So I thought maybe I should turn those off and see what happens. So initially I ran some experiments, and what I found out was that if you turn off this precision overdrive and force the CPU to only run in its stock frequency, then it would be a lot lower. The temperatures would be a lot lower. Then I went back, I tried to sort of make it so the single threading performance would be better. So I turned the precision boost back on and then tried to mess with the settings to make it cool and also have increased low thread performance. So I have actually a first generation Ryzen motherboard, which fortunately was upgradable to the 5000 series, but doesn't have the PCIe 4, but it still works pretty good. So to be able to do this, you need a motherboard with a good set of options to be able to manipulate these settings. So my understanding of this problem is that processors began to have a stock frequency and then a boost frequency, and the boost frequency needs some sort of infrastructure to kind of track things and allow more single-threaded sort of loads to increase their frequency, because fundamentally this is due because all the cores working together would overheat the chip. That's my assessment of this whole problem, is that the chips could go faster, but as a group they overheat. I think that's the problem. So in the case of the 5900X, the stock frequency is 3700 megahertz and the boost frequency is 4800 megahertz, which is 1100 megahertz over the stock frequency. So my theory was that this particular motherboard was kind of overclocking the CPU and sort of pushing it in higher voltages and higher frequencies than the CPU is really designed to do, and that was creating the extra heat that I couldn't personally get rid of, but maybe somebody else could. It did kind of work mostly properly, but I did have some weird behavior out of it from time to time. So there was an option, performance bias, which I believe I put to auto before, and in my intention not to overclock, I changed that to none, and I think that might affect the whole system, or I'm not exactly sure how it affects the system, but it is none at this time. So despite other person's interpretation of what the function of precision boost override is, it seems in this particular implementation, it is what controls the ability for the CPU to start increasing some of its cores as per a set of specifications. So leaving everything auto, there's really two things I changed. One is the maximum possible boost delta, I guess. It's 1100 megahertz. So that is in line with what the 5900X is rated for. So it doesn't try to do frequencies that it is not inherently rated for. And also I changed the wattage, the power to the CPU in terms of wattage maximum to 105. I started with a lower number and just went up and saw what it did, and hopefully it wasn't going to destroy anything. And I was pretty conservative, and 105 seems to be around where it needs to be for at least Blender to be happy with it, and most things be somewhere around between 70 and 80 Celsius. So after rebooting with new settings, I went to the fan auto tuning, so you could kind of calibrate what to do with the new kind of response you get for certain amounts of load for the CPU. So this is kind of off topic, but before this I went to the overclock auto tuner, and that doesn't really help you. What it does is it actually legitimately tries to overclock the system, and it actually altered the base frequency to 4200. So I was testing to see if it's basically stable, and the memory seemed to be stable, and I'm only running like 2400 memory in this system, and it's still getting pretty good rates. It's like the memory throughput, it says through this is somewhere around the level 3 throughput, which is, I would say pretty good, but I'm not sure how it gets this number, if it just is because of its particular way it gets the number. What was really frightening about this is when I went to 100% load in Blender, the system would actually go black and reboot immediately. So this thing about upping the base frequency really did not work very well whatsoever. And here's the clip showing when that happened. So here you can see the confirmation that the precision boost is in fact working, because I ran prime test with one core, and then I found the core that I was using, and it was higher than the 3700 base frequency. So that means that it was doing something. So this is Blender in pure CPU render, and it stays a little under 70 Celsius, under 100% loading. And I can see that I'm around 3800 megahertz on all cores, which is actually a bit of an overclock, but I'm not going to worry about that. So ironically, that prime test actually is cooler with the using all CPU cores. And I think there could be an issue with 100% utilization with different instructions could have different amounts of heat. It seems the prime test had more heat than the Blender did. So this is the combined CPU and GPU real-time path tracing for OptiX and cycles in Blender. When you're doing this, there's a render settings and there's a preview settings, and initially I didn't have it set up properly. You have a certain stop conditions, and then you have a denoiser setting. So at a certain point, I declared a low sample count and a denoising, and I don't think I was doing it at this point. So I should point out that this is one of the Blender demo scenes here, which I loaded just so it make for a very convenient geometrically complex test of how this whole system would work. Because it is real path tracing, you can see how physical obstructions scatter a light source. There seems to be some sort of compositing steps or something, so usually you don't see this gray thing here, and that kind of concerned me at the time, and fortunately I didn't terminate the rendering or something, but it sort of snapped back into doing something at this point, so it saved the day.